Greetings. You may have been taught the laws of indices and possibly had to memorize them. One of the problems I find with that idea is that you can't take the shortcut successfully if you're going to move on in mathematics without knowing how the shortcut was achieved. Somebody worked it out sometime, and we need to look at it. So there's several things here that I want to talk about. So let's just start off basically. If we have a, which is a number, to the power of m, and we're multiplying it by a to the power of n, another power, it might be the same, it doesn't matter, but in this case, what we do, as you've been told already, is that the answer is a m plus n. We're actually adding the powers because the powers themselves are already multiples and we're multiplying, so we just add the multiples together. That's fairly straightforward. Similarly, with divide, if we have a to the m over a to the n, then it equals a to the m minus n. This is fairly straightforward. This is less straightforward. We need to know that it is the numerator over the denominator, and therefore the denominator is subtracted from the numerator. If we had, for instance, in brackets a to the m itself to the power of n, then we multiply. So it's a to the m n. All I'm doing is reiterating the laws that you've probably already been told. Here's an interesting one though. A to the power of 0 equals 1. Any number to the power of 0 equals 1. It always will do. And maybe I can explain that later. Now we come to the higher levels of understanding of the laws of indices. That a to the minus m, i.e. we've got a negative value for the indice itself, is the same as the reciprocal, the 1 over, if you like, or a to the power of minus 1, of a to the m. In this particular case, hopefully we'll look at it later, in this particular case, it can be the number itself that's the reciprocal, or it can be the power that's the reciprocal. So watch out for that. We can look into more detail in that. If we have, for instance, a to the power of 1 over m, could be a half, couldn't it, is equal to the mth root of a, if you can say mth, I just made it up. And finally, we might have a to the power of m over n, and that equals the nth power of a itself to the power of m. Now, all of that is true. There's two things wrong, in my opinion, about learning it this way. The first thing is, if you memorize this from there to there, there to there, there to there, and so on, what happens if you're faced with, say, this one? And you're faced with it and it comes there and you want to find what it's equal to. It's not perfectly obvious because you've learned it this way. A to the power of 1 over m equals the mth root of a. A second thing that's wrong with that is that this 1, of course, is actually the one that's there. And it might not be a 1 there. So therefore you really need to analyze why this is true. Now, what is this? Well, actually, m to the power of a is going to be a to the power of 1 over m, but we then have to assume, and we do correctly, that this is the power of 1. But supposing it's not to the power of 1, how on earth do we get to this? We need to get to something. There's some way to get to it. Now, in this particular case, what we need to say is, I think personally, we need to use an example. An example might be therefore that, I don't know, a to the power of 2 over 3 equals the root. Now, what is the root? Well, it's going to be the 3, isn't it? And this is going to be a, what? Squared. Now, this is, it seems to me this is much clearer. Furthermore, supposing we had the cube root of a squared equals, how do you know? These laws of indices don't exactly tell you how we know what the answer is. Well, it's going to be, obviously, as we've just shown, a to the power of 2 over 3. It's the power over the root, yes? Power over the root and a to that value. So, without being told that, in my opinion, this becomes sort of meaningless, useful maybe for passing an exam, if, assuming the exam doesn't go any further than that, but if you're going to go from GCSE or level 2 or 3 exams, knowing these values, and then you go on to higher mathematics, you've suddenly got to learn it all again. So learn it now, is my opinion. Thank you.